Hi, welcome to Send to Print. In the last video, we modeled a twist fidget ball from scratch. And SMT Kelly left a comment asking, what about creating a cutter that allows you to cut any model into a twist fidget? That was such a brilliant idea, and challenge accepted. Now check it out. I built this strange looking cutter, and in this video, we're going to test the whole workflow together. Can we take a 3D model, work only inside the slicer, and turn it into a twist fidget without opening any modeling software? If this works, it opens up a lot of possibilities. So let's get started. I'm starting with a simple pumpkin image. We'll generate a 3D model from it, bring it into the slicer, and try to turn it into a working twist fidget without opening Fusion or any modeling software. There are tons of tools out there that turn images into 3D models. Most require credits or offer lower quality free versions. For a quick demo, I'm using the Image to 3D feature in MakerLab on MakerWorld. Scroll down to Image to 3D model and drag our pumpkin photo in. You can toggle between different models to see which one works best for you. That's it. Just upload your image, pick a model, and join the queue. Okay, it's done. If you like it, just go ahead and hit export to get the mesh. The cool thing is that it only uses credits when you export. That's reasonable, right? Choose STL and download it. Now let's drag it into the slicer. I'm using Bamboo Studio here, but other slicers should work in a very similar way. The generated model is sitting at an angle, so let's level it out first. Find the rotate tool, adjust the rotation until it is roughly level on the build plate. Check it from another view as well. That looks level. Okay. To fix the large overhang issue at the bottom, select the model and use the cut tool to slice off a small section from the bottom. Right around this position, the starting overhang angle is about 45 degrees, so it won't need extra support. And don't forget to delete the bottom piece. I think the pumpkin stem is a little too long, so let's trim it down a little. About here. Delete the extra part. Before we make the cutter, we need to know the size of the pumpkin it has to pass through. The model information is in the bottom right corner. For a quick test print, I'm going to scale it down a little bit. Find the scale tool. Here, you don't need to keep uniform scale checked. I'll set this dimension directly to 75 by 75 by 50. Now we can build a cutter around this specific size. It needs to cover the pumpkin without destroying the details we want to keep. I've uploaded the cutter as a parametric model on MakerWorld. You can open the link in the description, click Customize, and generate a cutter that fits your own model. There are only 4 parameters, but each one controls a different way the print can fail. First is the diameter. It must be slightly larger than the widest point of your model. This pumpkin is about 75 millimeters across, so the default diameter of 80 is fine here. If your model is around 90 millimeters across, enter 100 here so the cutter extends past the model and cuts all the way through every section. Next is the height. It must be slightly larger than the total height. The height of our pumpkin is 50 millimeters, so I'll change this to 60. This next value is the one that can quietly make or break the fidget. Pin slot height. It controls how high the internal captive pin slot goes inside the model. If it is too high, the slot can break through the surface. If it is too low, the pieces may not have enough room to slide. We'll measure this height on the model. Click the Measure tool. First, select the bottom face, then find a relatively low point near the top of the pumpkin. Here it shows 39.1 millimeters. We'll subtract 2 millimeters from that value. Enter 37. The last value controls the center hole. That small opening matters because it helps keep the inner tips from fusing together during printing and reduces friction when the parts twist. As you can see, our pumpkin has a stem sticking out from the top. If the core diameter is too large, it might cut away the entire stem, and that whole detail would disappear. So if you want to keep the stem, use a smaller core diameter. I'll set it to the minimum value, 2 millimeters. Click Generate. This is a third-party service, and the generation may take a little while. At this point, those 4 numbers carry all the decisions we just made: size, height, internal slot, and center clearance. Okay, the model is ready. Let's download it. You can choose either STL or 3MF here. Now, drag the cutter into the slicer. I'll switch to the top view so it's easier to align everything. Move the pumpkin roughly to the center of the cutter. It doesn't need to be mathematically perfect, but it should be centered enough for the twist structure to work. And make sure the whole pumpkin is inside the cutter so the cut goes all the way through. In Bamboo Studio, I need to merge the pumpkin and cutter before running a Boolean operation. Then I open the Boolean tool, select the pumpkin as the main body, and the cutter as the cutting tool. Choose Difference here. You can check Delete Input since we won't need the cutter later on, then run the cut. This is the moment of truth. If the cutter is wrong, the internal mechanism will either break through the surface or fail to form properly. This may take a little while because the Boolean calculation is pretty heavy. Okay, it's done. Time to see if it worked. The first thing I check is the top surface. The internal slot should not break through here. If it opens to the surface, the slices can escape instead of staying together. Now let's slice the model and look inside. The internal slot is there, but it does not break through the surface. That means the slices can slide, but they cannot fly straight out. Let's check the bottom too. Great, this side is also closed. I think our little cutter works well for this pumpkin test. Okay, send to print. While the printer is doing its part, let's turn this test into a quick checklist. What kind of model actually has a chance of becoming a twist fidget? From this pumpkin test, the pattern is pretty clear. First, a flat bottom is ideal so it can sit directly on the build plate. Second, the model needs to be solid inside. Do not use a thin hollow shell or the Boolean operation may not create the mechanism correctly. Third, aim for a height of at least 50 millimeters. If the model is too short, the slices won't have enough room to slide and the fidget won't feel as satisfying. The horizontal size matters too. You need enough material around the center axis to support the sliding mechanism, so I recommend at least 60 millimeters across the XY plane. The other question is how much cleanup you are willing to do. If you want to avoid supports, watch the overhangs from the bottom up and be careful with deep recessed areas like eye sockets. Finally, pay attention to the size of the details on top. If your model has a long, thin feature like this pumpkin stem, make sure it is thick enough and use a smaller core diameter. Otherwise, after the Boolean cut, you may end up with very thin areas that are easy to fail during printing, or the stem may be cut off completely and the detail will be lost. After almost 2 hours of printing, here it is, the pumpkin fidget we made with the cutter. The stem survived, the slot stayed hidden, and it twists really smoothly. So yes, the cutter worked on this pumpkin, and if your model follows the same basic rules, it has a good chance too. Alright, the cutter itself is free to download on MakerWorld for everyone, and as usual, channel members get early access to this video, plus a cheat sheet for the settings, and a behind-the-scenes Fusion file showing how the cutter was built. If you want to understand the mechanism more clearly, definitely watch the previous video. And if you want to make your own twist fidget quickly, you can find the link to the parametric cutter in the description. Try it on your own model, and if you make something wonderful or weird with it, I really want to see it. Okay, that's all for today. If you found this tutorial helpful, please hit the like button and subscribe for more 3D printing designs. Let me know in the comments what should I model next. Thanks for watching, and I'll see you in the next one.